An open source repo called Unsloth cuts AI training memory by 70%, letting you fine-tune an 8 billion parameter model on a used gaming PC from 2020. And it completely breaks the cartel of who gets to build artificial intelligence. The dirty secret of machine learning right now is that the raw processing power doesn't actually matter. If you read the mainstream headlines, the big labs want you to believe that training a model requires a data center, a billion-dollar valuation, and a dedicated nuclear reactor just to keep the lights on. And if you look at the February 2026 GPU market report, you can see why people believe it. Data center cards like the NVIDIA H100 surged 29% in price in a single month, while the median buyer for the new RTX 50 series desktop cards is paying up to 82% over MSRP. The hardware market is totally bifurcated, but for developers looking to build actual products, the real bottleneck has never been teraflops. It is VRAM. You do not need infinite compute to make a model smart, you just need enough video memory to hold its brain open while you perform surgery on it. Which means the actual meta right now is not a rack of enterprise servers, it is a specific 24GB consumer graphics card from 2020 called the RTX 3090. Because VRAM is the only metric that dictates whether an open weights model will crash your system with an out-of-memory error. A used card with 24 gigs of GDDR6X memory sitting in a dusty desktop has become the undisputed king of local development, outvaluing far newer cards that skimp on memory space. It is the best AI GPU for anyone paying out of their own pocket. But having the hardware is only half the problem, because standard fine-tuning is violently inefficient. When it comes to fine-tuning LLM architectures the traditional way, the math is basically a death sentence for a consumer PC. If you want to train an 8 billion parameter model, you don't just load 8 billion numbers. You have to load the model weights, and then you have to load the gradients, which are the directional updates for every single parameter. And then you have to load the optimizer states for your Atom W optimizer, which keeps track of momentum for every single parameter, so the training doesn't spiral out of control. By the time you boot up a standard Hugging Face pipeline, a completely modest 8B model will demand over 100 gigabytes of VRAM just to run a basic fine-tuning pass. Your 24 gigabyte graphics card will instantly choke, the kernel will panic, and your terminal will throw a CUDA out-of-memory error before the first epoch even starts. So the industry invented a cheat code. Instead of retraining the entire massive brain, you freeze the base model entirely. Then you inject a tiny, lightweight mathematical adapter into the side of it, and you only train that adapter. The technical term for this is low-rank adaptation, or LoRA for short. You are basically taking a massive, unchangeable matrix of numbers, decomposing it into two much smaller matrices, and training those instead. And to push the memory footprint even lower, we use QLoRA. The Q stands for quantization. We take the massive base model and we compress its precision from 16-bit floats down to 4-bit integers. According to the current VAST.AI hardware requirements tables, running QLoRA on a 4-bit 8B model drops the memory requirement down to about 6 gigabytes of VRAM. Suddenly, it fits. But fitting in memory and training efficiently are two very different things. Even with QLoRA, the standard Python libraries are bloated, slow, and leak memory like a sieve. Enter Unsloth. It was built by two Australian brothers, Daniel and Michael Hahn, who started it as an open source passion project before taking it through Y Combinator's summer 2024 batch. And they are currently backed by the GitHub Accelerator, the GitHub Fund, and Microsoft's M12 venture arm. Daniel previously worked at NVIDIA, where he spent his time manually fixing bugs in the core code of major open models like Llama, Gemma, and Phi, and building an ML acceleration library adopted by NASA. What Unsloth does is bypass the generic, slow abstractions of PyTorch. They manually rewrote the backpropagation math into highly optimized custom Triton kernels. They fuse multiple mathematical operations into single steps, which prevents the GPU from constantly writing intermediate steps back and forth to memory. The result is staggering. An Unsloth fine-tuning job runs up to 2 times faster than standard libraries, consumes up to 70% less VRAM, and mathematically guarantees 0 degradation in accuracy. Some of their optimized configurations even claim up to 30 times faster speeds with 90% less memory overhead. It turns a multi-day data center job into an afternoon task on a desktop rig. So let's actually build the pipeline. First, you have to source the hardware. And this is where the 3090 AI build comes with a massive asterisk. If you look at buying guides from the 2021 crypto boom, they all scream at you to avoid used RTX 3090s. Because during the Ethereum mining craze, these cards were run at 100% capacity in hot warehouses 24/7. The 3090 has memory modules mounted on the back of the PCB, which means those chips get notoriously hot, causing thermal throttling, melting thermal pads, and totally degraded silicon, especially on models like the EVG AFTW3. Buying a used 3090 is like buying a used Honda Civic from an underground street racer. You know it was abused. But today, you can grab one on the secondary market for around $600 to $1,000. If you replace the thermal pads and undervolt the card slightly, it remains the most cost-effective local AI hardware on Earth. You slot that into a basic motherboard with a decent power supply, and you have your physical infrastructure. Now you need a dataset to teach the model its new behavior. You cannot just dump a massive folder of unformatted PDFs into an LLM and expect it to learn a specific task. You need an instruction dataset. This is typically a JSON-L file containing thousands of examples formatted exactly how you want the model to behave, usually split into an instruction, an input, and the ideal output. A recent walkthrough published in Towards AI by Bhavya Fatania demonstrated how Unsloth fine-tuning has turned this entire process into a free tier task. They took a current small open model, Qwen3, and trained it to write highly specific code using an 18,000 example Python instruction dataset. You format your JSON data, drop it into your project folder, and move to the code. Next, we establish the training environment. Historically, doing this on a Windows machine meant fighting with Windows subsystem for Linux, dealing with driver mismatches, and essentially configuring a Linux partition just to get the Python libraries to talk to your GPU. But Unsloth recently shipped Unsloth Studio. It is a no-code web UI that supports over 500 open source models, and crucially, it runs natively on Windows without WSL. It even supports CPU-only machines for basic data tasks and handles Mac hardware through MLX. You point Unsloth to your base local LLM, and it handles the complex quantization steps under the hood. It downloads the massive uncompressed weights, instantly converts them to a 4-bit format, and maps them entirely into the VRAM of your single 3090. Now the part that actually unlocks it, you trigger the training run. This is where the Han brothers' custom Triton kernels take over. Under normal circumstances, calculating the loss curve during training requires saving massive intermediate tensors to memory, which spikes your VRAM usage and crashes the run. Unsloth bypasses this by calculating the loss natively in lower precision and discarding the garbage data instantly. You will literally see your terminal outputting a steadily dropping loss metric as the LoRA adapter learns the specific patterns of your dataset. A standard fine-tune that would take 14 hours on normal Hugging Face pipelines finishes in about 6 hours. The developer tooling platform Check.AI recently ran a massive roundup of the current landscape, testing tools like Axolotl and TorchTune, and crowned Unsloth the absolute speed king for single GPU workflows. When the progress bar hits 100%, you don't have a massive new model, you just have a tiny megabyte-sized adapter file. You merge that adapter back into the base model, and your capability is fully unlocked. But the real question is whether this consumer-grade setup actually matches lab-grade outputs. Because for a long time, the assumption was that a LoRA adapter trained on a single card was a neat toy, but fundamentally inferior to a full-weight fine-tune done on a proper server cluster. An independent researcher named Benjamin Marie, who writes The Kaitchup, put this to the test. He took the state-of-the-art supervised fine-tuning recipe from AI2, called Tulu 3. The original researchers trained that model using multiple heavy GPU nodes, throwing massive enterprise compute at the problem. Marie took that exact same recipe, loaded it onto a single 24 gigabyte consumer GPU, and ran it using LoRA and Unsloth. The results proved that the consumer hardware could reproduce near lab-grade outputs. It is no longer an open question whether a solo developer in their bedroom can output enterprise-quality model behaviors. They can. Now, obviously, if you do want to scale past a single machine and orchestrate training across massive distributed clusters, there are tools for that too. The parallel project in the open source space is Colossal-AI, developed by HPC-AI Technology and founded by Professor Yang Yu out of UC Berkeley. They recently raised $50 million to expand their platform, which handles the complex distributed systems side of the equation and powers massive projects like OpenSora. But for the vast majority of generalist builders, the single-node setup is the endgame. You don't need a $50 million cluster to build a product with genuine leverage. You just need a dusty graphics card from 4 years ago, a clean dataset, and an open-source library that refuses to waste your memory. You didn't miss the AI revolution, you just assumed you couldn't afford the hardware.